In this video, we are going to discuss translations. A translation just means to slide, which we talked about in our vocabulary already. A preimage can slide left or right. If we slide left, that's a minus, and if we slide right, that's a positive. Or we can slide up or down. If we slide up, that's a plus. If we slide down, that's a minus. So we slide the preimage to obtain an image. Translations preserve congruence. That means that the preimage is going to be congruent to the image. That means that the image, if it's congruent, that means it's the same shape and size as the preimage. Remember that when two figures are congruent, their shape and size is the same. That means that the angle measures are equal. You guys always remember that the side lengths are equal, but sometimes you forget about the angle measures also being equal. Translations also preserve orientation. So preserve means that the preimage and the image are the same. So the orientation in my preimage and image are the same. That means that the shape faces the same way in the coordinate plane. I say the shape, I mean the image and the preimage. The general rule for translations is we'll start with an ordered pair x comma y. This arrow means that we're transforming that coordinate, and we need a new ordered pair here. So we'll have x, and we add or minus a number from x to get to the new slide. I'll call that number h. The second coordinate is always a y value, so I've got y, and again we're either adding going up or subtracting going down to get to the new ordered pair. We don't know what that number is, I'll just call it k. Now this is page 120 on the front, and there are some examples on this page, but I would like to look at the examples on the back first. I just couldn't fit I couldn't fit the graph on the back, so I wanted to put that on one page by itself. And we'll call this example 1. Here I've got a pre-image of coordinates A, B, and C, and I want to translate that shape right 6 times and up 2 times. So I'm going to have to actually plot those points down here. A was at negative 3, 5, negative 1, 2, 3, 1, 2, 3, 4, 5. B was at negative 1, 2. And C was at negative 4, 2. So there's my shape. The translation we want, so I've plotted those points. The translation that we wanted to do was move this right 6 times and up 2 times. So we're going to do that by actually moving every single vertice, every single point on this triangle, right 6 times and up 2 times. So we'll go right once, 2, 3, 4, 5, 6 times, and up twice. And that's the new A, so I call that A prime. I have to do that same thing with B and C as well. So I'll take point B and I'll move it 6 times to the right, 1, 2, 3, 4, 5, 6, and 2 times up, 1, 2. There's B prime. I also have to do that with the last point, C. I have to move this right 6 times. 4, 5, 6, and up twice. And there's C prime. So there's the new triangle. You can see that this triangle is the exact same triangle. We just picked it up and moved it. We moved it to the right and up. This is the pre-image because it doesn't have the prime notation. This is what we started with. This is the image. This is where we ended after we've slit our triangle. So we have a question here about the image coordinates. So we want to write the coordinates for A prime, B prime, and C prime. A prime is right here. That is 3, 7. A prime is 3, 7. Now let's look at B prime. B prime is 5, 4. And we need C prime as well. Here is C prime. That is located at 2, 4. Next, the question asks, well, how does each coordinate or x coordinate change? So how did I go from -3 to +3? How are we moving from -1 to 5? What's the difference between -4 and 2? Hopefully you guys can see the pattern here is that each one of those x coordinates is getting bigger by 6, or that we are adding 6 to the x coordinate. How is each y value changing? We went from 5 to 7. How do you go from 2 to 4? What's the difference between that 2 and the 4? Those numbers are also getting larger or bigger by 2. That means that we are adding 2 to the y value. So to write a rule for the translation, we always start with x, y, the original ordered pair. The arrow tells me there's a transformation. Now we're going to write the new ordered pair using this how did the x value change and how did the y value change. So the x value got bigger by 6, or we added 6 to the x value. So the new x value is x plus 6. The new y value is 2 larger than the original y value, so y plus 2. So you can see we got bigger 6 times with our x value, or x added 6 to get to the new image. And to go from pre-image to image for the y value, we also got bigger, so we added 2 times there. Let's look at the second example now. I only have one graph below, so I'm going to use different colors to kind of help me differentiate between the examples here. And I'll see if I can't make this image a little clearer for you guys. Okay. Here I've got a pre-image, R, S, and T. R is at 3, 4. So 1, 2, 3, 1, 2, 3, 4 is R. S is at 5, 2. S is at 5, 2. And T is at 1, 2. So here I have another triangle. This tells me to translate translate the triangle left 3 times and down 4 times. So kind of like we did with the red triangle, we're going to actually move every vertice, every point on the triangle 3 times to the left and then down 4 times. So we're going 3 times left, 1, 2, 3, and then down 4 times. 1, 2, 3, 4. I moved point R 3 times left and 4 times down. So this is called R prime. Again, we're moving 3 times to the left and 4 times down. 1, 2, 3, 1, 2, 3, 4. We just moved S 3 times to the left and 4 times down to get S prime, or the new S. Now let's move T. Let's find where T prime is. That's 3 times left and 4 times down. Now I can connect my new triangle, and this is the image. That first question is going to ask me what are the new coordinates. We can see R is at the origin, R prime is at the origin, 4, 0, 0. Let's find S prime. Its location is now at 2, negative 2. S prime is at 2, negative 2. Here's R prime, here's S prime. Now we need T prime. T prime is at negative 2, negative 2. Okay, now it's not a coincidence. We moved left 3 times. Right and left affect the x values. When I look at the x values, we started at 3 for R and went to 0. We got smaller by 3. 5 to 2 got smaller by 3. 1 to negative 2, we got smaller by 3. The x values are changing by minus 3. How are the y values changing? That was going down 4. Let's see if that makes sense. With R, we started at a y value of 4. R prime is 0, so we minus 4. To go from 2 to negative 2, you minus 4. 2 to negative 2, minus 4. So all of the y values are changing by subtracting 4. So when I write the rule for this translation, we start with x comma y. The arrow just means some sort of transformation is happening. We get a new x value. How did the x coordinate change? By just minusing 3 from the old one. The old one is x. Now I need to minus 3 from it. To get to the new y value, I need to know how does the y value change. So we just minus 4 from whatever the old y value was. The old y value was y. So y minus 4 is the new y value. Okay, next we'll look at this translation. M, N, and O. M is located at negative 3, negative 1. Negative 1, 2, 3, negative 1 is M. N is located at negative 6, negative 1. Negative 6, negative 1 is N. And P is at negative 3, negative 4. P is at negative 3, negative 1, 2, 3, 4. This is P. Again, I've got a triangle. Let's see what our goal is with this right triangle, actually. we need to move the right triangle, or translate or slide the right triangle left 6 times and then up 8 times. Left 6 and up 8. So I'll start with point P. I need to go left 6 times and then up 8 times. 1, 2, 3. That's going to the right. I need to go left 6 times. Left 1, 2, 3, 4, 5, 6 times, and then up 8 times. 1, 2, 3, 4, 5, 6, 7, 8. That was P that I just moved, so this point is called P prime. Now we'll move N. I need to go 6 times to the left. 1, 2, 3, 4, and I'm off the grid twice. And then I need to go up 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Get me N prime. That's on, I'm going to write the ordered pair just for reference. We went up to the y value 7, and that was twice after we were finished counting. So that was 1, 2, 3, 4, negative 11, negative 12. So the location of N prime is negative 12, 7. Now let's move M to find M prime. This translation says to go left 6 times and up 8 times. 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5, 6, 7, 8. And that is M prime. So here is my translated triangle. And this is the image because it has the prime notation. So that first question, it just wants to know what are the coordinates of the image. We already know that N prime is negative 12, 7. Now let's look at P prime. P prime is negative 9, 4. And then M prime is negative 9, 7. Let's see if there is a pattern or a correlation, some sort of recognition between going left 6 times and up 8 times. Going left and right affects the x value because that's moving on the x-axis. So we went from negative 3 to negative 9. This is M and M prime. Went from negative 3 to negative 9. So negative 3 minus 6 gets us negative 9, and we did go left 6. You can see that we do just subtract 6 from each of our x values to get to the new x values. So we started with N at negative 6, and N prime is at negative 12. Negative 6 minus 6 is at negative 12. And P had the same x value as M. So when we go left 6 times, we are minusing 6. When we go left, we minus. That means when we go right, we add. And those things affect the x values. How do the y values change? Y values are going up and down. We went up 8, so let's see if there's some sort of pattern or something that we recognize between the old x values, or y values, the new y values, and the number 8. As an example, we'll look at M. We started at negative 1, and we ended at 7. Negative 1 plus 8 gets us to 7. N has the same y values. And then P, we started at negative 4, and we ended at 4 for P prime. So negative 4 plus 8 gets us to 4, which means we were just adding 8 every single time to our y values. So for our y values, if we are going up, then we add, and if we go down, then we minus. We're going to use the fact that we minus 6 with the x value, and we added 8 with the y values to write a general rule for a translation that says to go left 6 and up 8. We always start with x comma y, the original ordered pair. The arrow says that some sort of transformation is happening. Our x value, we need to minus 6 from it, so we'll have x minus 6 in our rule. And any y value on this triangle, we find the new one by just adding 8 to it. So y plus 8. The rule is important because now I don't have to count out going left 6 times and up 8 times. I can just write some general rule for it, and then you could find any arbitrary ordered pair that you would want. I need another color for this last example because I only have one graph. So we'll call this example 4. That is a really bright green. Here's an orange. We'll call this example 4 and orange. We're going to start out with the pre-image coordinates 6, -5, 3, -3, and 4, -4. That is 6, -5, 6, -5. That is A. B is at 3, -3. And C is at 4, -4. And I don't really think this makes a triangle so much as a line. A weird line. Okay, and I want to translate or slide that line right 5 times and down 3 times. Right 5 times we think would mean to add 5 to the x values. And down 3 times we think would mean to minus 3 from the y values. Let's see if that's kind of what happens. We're moving the orange triangle right 5 times and down 3 times. Not triangle, sorry, line. Right 5 times, so 1, 2, 3, 4, 5, and down 3 times, 1, 2, 3. That gets us, we just moved B, so this is going to be B prime. When I move the original C 5 times to the right and 3 times down, I get C prime. Now A would go 5 times to the right, 1, 2, 3, 4, and I'm off the graph here at 11, and then down 3 times, 1, 2, 3 at -8. So 11, -8 is the ordered pair for A prime. Again, just a little bit off the graph. And you can see that it's the exact same weird line, just moved to the right and down. So the image coordinates, we know that A prime, we just wrote that down, 11, -8. B prime is at 3, -3. I'm sorry, that's B. 3, -3 is B. B prime is 8, -6. And C prime is right here at 9, -7. And you can see that pattern still holds. Each x value got bigger by 5. 6 plus 5 is 11. 3 plus 5 is 8. 4 plus 5 is 9. And down 3 times. -5 minus 3 is -8. -3 minus 3 is -6. -4 minus 3 is -7. So the x coordinates changed by adding 5. The y values changed by minusing 3. So the rule, when we start with xy, is to add 5 to the x value, x plus 5, and to minus 3 from the y value, so y minus 3. this was just graphing translations. I'm going to take a second video so that I don't take up too much time to talk about translations when we don't have